How to take on a two-tailed t-test. In example 3, it says a marketing researcher wants to estimate the mean savings realized by shoppers who showroom. Showrooming is the practice of inspecting products in retail stores and then purchasing the products online at a lower price. A random sample of 100 shoppers who recently purchased a consumer electronics item online after making a visit to a retail store yielded a mean savings of $58 and a standard deviation of $55. Is there evidence that the population mean savings for all showroomers who purchase a consumer electronics item in different room is different from the $50? Use a 0.05 level of significance. So basically what this is you go inside of a store, you see an item you like, you go to Amazon to purchase it instead of buying it in the store. Try to save some money. They want to know, is the amount of money you save different from $50? And by different, does that mean you save more? Does that mean you save less? We don't really know. They're just saying that it's different. So because this word is different, we have what's called a two-sided test. And so when we establish the null and alternative, HO is that mu is equal to $50, and HA is that mu is not equal to 50. And so when we do this, again, we're going to identify the statistics that were given to us. It tells the mean savings, X bar, is equal to 58, and the standard deviation, S of X, is equal to 55. And we've done this for a sample of n equals 100. We're testing at the 5% level of significance, so alpha equals 0.05. So let's go find our t statistic and our p-value for this. So again, this is just a test. So we'll press stat, test, t-test. And the first thing that asks is, what is the null mu? So the null mu is 50. Our X bar is 58. Our standard deviation is 55. And our our sample size is 100. This time though, notice again I have to pick the right direction. If you look at the picture, my calculator now graph the actual t-values for me. You could draw this though. In a two-tail test, you need to check both tails. So right now it's only checking the right, and it's because it's set to greater than. Likewise, if I pick the middle one, it'll set the left, and it's checking the left tail. This one, though, I'm doing a two-tail, so I'm just going to check both tails. So watch what happens. It splits the value. It splits the value on both sides now. Splits the normal curve on both sides. And so here I see that my t statistic, t is equal to 1.455. And the p-value for that is equal to 0.149. Now, before we continue, I want to show you how to do this in your calculator again. And remember, we can do it in our calculator by finding the actual t statistic, where t is equal to X bar minus mu divided by S of X over the square root of the sample size. So if I calculate that, here's what I get by hand. I get 58 minus 50 divided by, in parentheses, 55 divided by the square root of 100, which is just 10, by the way. I get that same t-value, 1.455. And remember, what that really says is this. Now, in a two-tailed test, here's how it's different. When you draw your curve, what's happening is the actual tail can either be, here's 0, it can be here or here. Here is the t-value of 1.455. The other value that corresponds to that is also a negative 1.455. The good news is that the area located in both of these is the exact same. Now, we know that that area from our calculator should be this 0.149. So to calculate that 0.149, again, we're going to use the TCDF. And remember, for TCDF, you need degrees of freedom. Well, my degrees of freedom here are equal to 99. And I'm going to calculate this one right here on this side. So I know I need to go to positive 999 like that. So I go second bars, and I'm going to use the TCDF function. The upper bound here, or the lower bound here, I'm sorry. The lower bound is starting here at 1.455. The upper bound is going to 999. And I need a degree of freedom, which is 99. When I do that, I get this right here. Well, the answer that we saw from the calculator was this value, 0.149. This is not that answer. But that's because this answer that I'm getting right now is only giving me the right tail. I need this tail as well. The good news again is that they're the exact same value. So all you have to do is multiply this by 2. And look what we get. We get that 0.149, which is what I have sitting right here. So I'm telling you that because in the two-tailed test, if you calculate it by hand, which you won't have to do, but if you need to know how to do that, if you calculate it by hand, whatever you get for one tail, you have to multiply it by 2 to get the second tail as well. So let's finish this problem off now. To finish it, answer the question, is there enough evidence? Well, our p-value is 0.149 and our t-value is 0.05. 0.149 is greater than 0.05. And when the p-value is greater than the alpha value, we fail to reject. Why are we failing to reject? Because there is not enough evidence to support the alternative claim. Just like if I fail to reject your innocence, you are still innocent. Why are you still innocent? It wasn't because you didn't commit the crime. It was because I didn't have enough evidence to suggest that you did. So this is exactly what you're doing here.